Hello, class. We want to welcome you in class today. Today we want to look at chapter 1, which is we're going to be studying matter, measurements, and we'll look at some problem solving. So before we talk about look at the study of matter, let's talk about scientific approach of knowledge. How do scientists think? How do they come up with ideas? How do they come up with the theories that what scientists do first, they observe. And after observation, they conduct experiments in order to confirm what they observe. But scientific knowledge is based mainly on observation and experimentations. But what they do first, they do observe. And in observation, there are two things that they are searching for. They look at the qualitative process. They observe by looking at the qualitative process, that is, noting and describing how the process works. For instance, they look at the color. They look at some physical properties like melting point, boiling point. For example, if they want to look at Coke, they'll look at the color of Coke. The color of Coke is brown, yes. That's the color of Coke. That's an observation. That's a qualitative observation. Then they can look at quantitative processes. They'll look at the quantitative processes. The sweetness of Coke. That is its quantity. How much sugar is in Coke? So that is quantity. Coke is sweet, but what is the mass of sugar that gives it its sweetness? In that case, we are dealing with quantitative. So in observation, you're observing the qualitative processes like color, melting point, boiling point. Then quantitative, you're looking at the quantity, the mass, the length, and how it affects the observation. But after observation, what do you do next? What happens after observation? When scientists observe, what they do next is try to interpret or try to explain the observation in such a way that it will make sense. They look at some trends and they try to make the explanation. For example, soda is sweet. Why? Is it because of the presence of sugar, or there's something else that's making it sweet besides sugar? They ask questions while they observe. And in the course of asking the question, they can give an explanation. That tentative explanation or interpretation is what we call a hypothesis. So after observation, Scientists draw a hypothesis. Hypothesis is a tentative explanation. No experiment has been done. They just want to explain. They are not sure whether it will hold. After the explanation, which is based barely on observation, what scientists need to do, or what they normally do, they cannot just leave it like that. They have to do some kind of a test. And that is the next step, experimentation. Experimentation is done. Experiments are carried out in order to support the hypothesis. This experiment can prove the hypothesis to be wrong, and in such a case, they discard it. But if it supports the hypothesis, that's fine. But if it doesn't support the hypothesis, what is done is that the hypothesis is discarded or the hypothesis is revised for further experimentation. But if the hypothesis or the experiment support the hypothesis, then a summary is drawn. And that summary, which is an overall observation, is what we call a scientific law. So a summary can be verbal or it can be mathematical. So when that summary is reached because the experiment support the hypothesis, we call that a scientific law. Now it is a law because the observation is seen in a broad sense. It supports all of nature most of the time. The scientific law is an observation that supports most of nature, like gravity. Anything that goes up must fall. So we can see something here about Lavoisier. He lived in 1743 to 1794. He conducted some experiments. He observed something. He observed that masses of objects in closed containers remain the same before and after burning. The mass does not change. It remains the same before and after burning. So after he observed that, he conducted the experiment and he came up with a law. And that law, we call it the law of conservation of mass. And it states that in a chemical reaction, matter is neither created nor destroyed. In the chemical reaction, in a closed container, matter is neither created nor destroyed. So that is a law. We have other laws, like I said earlier, the law of gravity. We have the law of reaction, action and reaction. For every reaction, for every action, there is a reaction. So those are scientific laws. So, from specific to general understanding, a hypothesis is a potential explanation for a single or small number of observations. Take note, single or small number of observations. So a potential explanation. So in hypothesis, you just observe and you come up with an explanation of your observation based on the trend on what you see. Then a theory now is after you have conducted an experiment and this experiment supports your hypothesis, then you can come up with a general explanation for what you have observed. That is a hypothesis and of all nature. I mean, that is a theory, not a hypothesis. So most of the time, a theory is valid for models, is valid for pinnacle of scientific knowledge. So is valid because you have conducted experiments that support the hypothesis. So you can come up with a theory. So specific explanation is for small and single and small number of observations. Then theory is general explanation for the manifestation and behavior of all nature. So we want to look at some kind of a summary, a table. So relationship of scientific methods. So when we look at single and small number of events, and we observe it, we call it observation. Observation is what describes what happens in single and small number of events. So that's observation. But when it applies to large events, we call it a law, scientific law. Law. Hypothesis applies to small number of events, explanation that happens in small number of events. Here, no experiment has been done, no experiment. You just observe and explain. But after experimentation, we come up with a theory. And it applies to all the events. So this is how scientists solve problems. This is how scientists think. So if you're going to be a scientist, you observe, and remember, observation is qualitative or quantitative. After observation, you come up with an explanation which we call a hypothesis. After you come up with a hypothesis, you have to test your hypothesis. That is, you conduct experiments. After conducting experiments, if they support the hypothesis, then you can now come up with a theory. But if this observation is general for everything in nature, then we can draw a scientific law. So in order to check whether you understand this, let's look at these checks. What is the difference between a scientific law and a scientific theory? Try to explain it. Think about it. We have just talked about it. Look at it and think about it. What is the difference between a scientific law and a scientific theory? Try to think about it and come up with a difference. Then